When you think of artificial intelligence, your mind probably jumps to self-driving cars, thinking machines, a world built on code and silicon. We see it as the absolute peak of modernity, a technology that's literally defining our future. But what if I told you the first real steps towards AI weren't taken in Silicon Valley but here, in the Roman Empire? It's easy to think of AI as our modern marvel, but its origins might just trace back thousands of years. This is the story of the surprising automated machines and deep philosophical ideas that suggest the Romans and the Greek minds they absorbed were already grappling with the concept of artificial beings long before a single computer was ever imagined. Before the first gear ever turned, the idea of artificial life existed in the most powerful processor known to the ancient world, the human imagination. The Greco-Roman world was soaked in mythology, and these weren't just campfire stories. They were complex thought experiments about gods, humanity, and the very nature of creation. And hiding within these myths, we find the conceptual ancestors of AI. The most famous is Talos, the bronze giant. Forged by Hephaestus, the god of invention, Talos was a massive automaton, a living statue of bronze. His mission was simple, but his existence was profound. Protect the island of Crete by circling its shores 3 times a day and hurling giant rocks at any pirates who dared approach. Talos wasn't born, he was made. He was an engineered being with a specific program: patrol and protect. His body was invulnerable, except for one critical design flaw. A single vein ran from his neck to his ankle, pulsing with divine fluid called ichor, and it was all sealed by a single bronze pin. This wasn't just a weakness, it was a kill switch. His defeat didn't come from brute force, but from what we'd call a hack. The sorceress Medea tricked him, pulled the pin, and he effectively bled out. The story of Talos shows that ancient thinkers were already playing with the idea of a created being that mimics life but has a mechanical and therefore fallible nature. But Talos wasn't a one-off. His creator, Hephaestus, was basically a divine engineer, and his forge on Mount Olympus was a factory of wonders. Homer's Iliad describes his most incredible creations: a team of golden handmaidens, and these were not just shiny statues. Homer tells us they looked like living women, and crucially, there is intelligence in their hearts, and there is speech in them and strength, and from the immortal gods they have learned how to do things. They were his assistants, his support staff, helping him move around. They weren't mindless machines. They were described as having understanding and the ability to learn. Myths even tell of Hephaestus creating other automata, like gold and silver guard dogs for a palace. Of course, these myths weren't technical manuals. They were the software of the ancient imagination. They show us that long before the engineering was possible, the dream was already there. The big questions were already being asked. Can something that is made, not born, be considered alive? Can it think? What's the real difference between the living and the lifelike? This groundwork, inherited and built upon by the Romans, was the necessary first step. Before you can build the hardware, you must first imagine the software. As the Roman Empire grew, it absorbed the intellectual fire of the Hellenistic world. The new Silicon Valley of antiquity became the city of Alexandria in Roman-controlled Egypt. This is where the mythical dreams of Hephaestus met the practical genius of human engineering. Alexandria was home to the Great Library and the Museum, a research hub that attracted the brightest minds from all over. Engineers like Ctesibius and Philo of Byzantium were tinkering with pneumatics, hydraulics, and mechanics. But one name rises above them all, a man who took their work and turned it into an art form, Hero of Alexandria. Living around the 1st century AD, Hero was the Tony Stark of his era, a brilliant mathematician and engineer. He wasn't just a theorist, he was a builder. He documented his incredible creations in detailed books like Pneumatica and Automata Poetica. Hero turned abstract physics into marvels that blurred the line between science and magic. Maybe his most famous invention was the automatic temple doors. Imagine being an ancient worshipper. A priest lights a fire on the altar, and then, as if by a divine sign, the massive temple doors swing open all on their own. The mechanics were brilliant. Heat from the altar fire expanded air in a chamber below, which pushed water into a bucket. As the bucket got heavier, it descended, pulling on ropes and pulleys that opened the doors. When the fire went out, the air cooled, siphoning the water back, and the doors closed. It was a perfect, automated sequence designed to inspire pure awe. But Hero's genius didn't stop there. He created what was arguably the world's first vending machine. It didn't dispense snacks, but something much more valuable there: holy water. A worshipper would drop a coin into a slot. The coin's weight would tip a lever, opening a valve and releasing a set amount of water. As the lever tilted, the coin slid off. A counterweight snapped the lever back, and the valve closed. It's a simple, elegant system that performs a specific task for a specific input, the very essence of automation. These devices are astounding. They reveal a level of mechanical smarts that challenges our whole picture of the ancient world. If this is blowing your mind as much as it does mine, take a second to like this video and subscribe for more journeys into lost history. Your support really does help bring these ancient wonders to light. The temple doors and the vending machine were amazing single-task automations. But Hero's most mind-bending creation, the one that gets eerily close to our idea of programming, was his automated cart. This wasn't just a machine that did one thing. It was a device that could be programmed to follow a complex path with turns and pauses completely on its own. The cart was powered by a simple falling weight connected to a cord wrapped around the axles. The secret to its programming was how those cords were wound. By using pegs on the axle to change the wrapping pattern, Hero could dictate its movements. When the weight was released, the cord unwound, turning the wheels. But when the cord hit a peg, it would shift how it was wrapped, making one wheel turn differently than the other, resulting in a turn. This system was basically a form of physical instruction. One wrapping pattern meant go straight. A different pattern meant turn left or turn right. By arranging the ropes and pegs in a specific sequence beforehand, Hero could predetermine its entire journey. He even created 10-minute-long mechanical plays using a similar system of ropes and rotating cylinders to move figures and create sound effects. Now, this wasn't AI. The cart couldn't think or adapt to a surprise obstacle, but it was, in a very real sense, executing a program. It was following a pre-written set of instructions, stored not in silicon, but in string. That's a massive conceptual leap, the idea that a machine could follow a complex sequence of commands without any more human help. It's the same fundamental principle you see in a player piano or a music box. And we can't forget the most complex piece of machinery to survive from the ancient world, the Antikythera Mechanism. Discovered in a Roman-era shipwreck, this Greek device from around 100 BCE was a mind-blowing analog computer. With its system of over 30 intricate bronze gears, it could predict astronomical positions, eclipses, and even track the 4-year cycle of the Olympic Games. Though Greek in origin, its presence on a Roman cargo ship shows this level of mechanical genius was part of the Roman world. Like Hero's cart, it wasn't intelligent, but it was processing data using gears to compute the cycles of the cosmos. So, with all this incredible tech, automated doors, vending machines, programmable carts, and cosmic calculators, did the Romans have AI? The short answer is no. But they were absolutely circling the concept. What they had was a mastery of automation. Their devices, the automata, were marvels of engineering designed to follow a fixed set of instructions. Hero's temple doors would always open the same way in response to fire. His cart would follow its pre-wound path. And only that path. It's what we'd call a classic if-then system. If the fire is lit, then open the doors. The purpose of these machines was also different. They weren't built to replace labor, but to inspire wonder, to entertain, and to project religious or royal power. They were technological theater, designed to make people feel like they were in the presence of gods. The crucial element that was missing, the spark that separates an automaton from true AI, is the ability to learn and adapt. Modern AI isn't just about following a program. It's about analyzing massive amounts of data, finding patterns, and changing its own behavior. An AI-powered self-driving car doesn't just follow a preset path. It perceives the world in real time and makes decisions. The ancient world, through Greek philosophers like Plato and Aristotle, debated the nature of the soul, intelligence, and thought for centuries. They asked what it truly means to understand. Plato believed true understanding was a quality of the soul, something intuitive and far beyond mechanical calculation. Aristotle made distinctions between different kinds of intellect, some tied to our senses and others that could grasp abstract ideas. So you could say the Romans and the Greeks before them had the two halves of the puzzle, but they were in separate rooms. In one room you had the philosophers thinking about the software of consciousness. In the other, you had engineers like Heron building the hardware of automation, proving machines could act on their own. They never quite brought the two together. They built machines that could act, but not machines that could learn. They imagined beings with intelligence in their hearts, but their real-world creations had intelligence only in the careful arrangement of their gears and strings. When the Roman Empire fell, a lot of this incredible knowledge was lost for over 1,000 years. The mechanical complexity of Hero's automata and the Antikythera Mechanism wouldn't be seen again until the great astronomical clocks of late medieval Europe. It's a powerful reminder of just how fragile progress can be. The Romans didn't have artificial intelligence as we know it. They couldn't ask a machine a question or have it write a poem, but they inherited and built upon a powerful legacy. They lived in a world where the idea of artificial beings was explored in myth, where the nature of intelligence was a hot topic for debate, and where engineers were proving that machines could achieve a startling degree of autonomy. They laid a foundation not of code and circuits, but of ambition and imagination. They showed that it was possible for a non-living thing to perform a task, to follow a path, to create wonder. The quest to build artificial beings didn't start with the computer. It began with a story, a gear, and a puff of steam. And in that quest, the ancient Romans were much closer to the beginning than we ever imagined.